All right. Good morning, good afternoon, good evening, no matter where you are at. Thank you for coming today or clicking on that video. This is the CDK office hours. My name is Matthew Boddick, and today we're going to be talking about a bit of a different topic. A lot of times in the previous videos, I've been going through and just kind of sharing with you some ways to use different CDK constructs and talking about the new hot swap feature. Well, today I wanted to take a step back and chat a little bit about the CDK and object-oriented programming in general, because the CDK is a great tool in my mind. I came from an application development background, so for me it was very easy to adopt TypeScript and JavaScript or even Python to go and start defining infrastructure. But for a lot of people who were responsible for managing infrastructure in the past, they may not have come from a programming background and may be more familiar with shell scripts or static files and not understand some of the concepts within these object-oriented programming languages. So I want to cover those today as a bit of a primer for anybody who may still maybe a little bit confused over terms like inheritance and interfaces and what these mean in the language and how you use them specifically with the CDK. So this isn't going to be a full deep dive into OOP by any means, but it is meant to be sort of a what are the basics you need to know to be able to work effectively with the CDK. So let's get started. I'm going to go all the way back sort of to the beginning and talk about the very simple basics of programming languages, not even touch OOP. We're just talking about variables for a moment. So let's say I start off and I've got here, this is my Webstorm. This is a simple TypeScript project, and I have just a blank slate of code to write at this point, nothing really written. Down here at the bottom, I've got my terminal window, and this will places where I can go and run that code and show you how it works and what it does. This is Webstorm. You may use VS Code. It works very, very similar. Some of the features are a little bit different, but that's not going to hopefully matter too much for our discussion today. Additionally, this is going to be largely and totally done within TypeScript. Other languages like Python, Java, C#, they're going to have all the same concepts. The syntax might be a little bit different, especially Python, but all the basics are still the same. We talk about variables, we talk about classes, inheritance, all those things. So if you go through this and the syntax doesn't make sense to you because you're using Python, any basic Python docs on OOP and the things we talk about will be a good place to go to after this. So let's start with the very basics. I can create a variable, say, let's say I'm trying to work with modeling an automobile within my software. I want to represent a particular car, an actual car in this world. Maybe I'm eBay Motors, or maybe I'm Doug DeMuro or whatever. So I can create a variable in my language, and this variable is just a holding block for or name for some value. So I can say the make of my car is a Ford. So in this case, I've created a variable that I've just defined the name of directly. I just decided it was make. I could have picked anything I wanted to here. And then I give it a value. In this case, it's what's called a string value that represents normal characters and words and things like that. And we always have to enclose those with double quotes in almost every system. So it's a very common thing to see when you see double quotes around something, that's a string. Now I can keep defining variables, like I can now say the model is a, it's a Ford probe. This again is a new variable in the system. It's called model. I picked that name myself, and it has a value of probe. And of course, I can change that value over time in most situations and say, well, the model is something else. Maybe I made a typo or whatever. I can also create a number value. So I can say 1992. Now, notice there aren't the double quotes around it, which means that this is a number to the system. TypeScript in most languages will treat this as a number, which is a sort of a unique situation within the code, neither here nor there. And finally, I can also, maybe this is a real car, so I care about, is it running? And I can say that that's a Boolean value, either true or false. Those are the only two values. It can be Boolean, yes or no, true or false. Okay, so I got my four variables here, and that's great. Now there's a fifth type of variable that we can deal with in almost every system, in any language, called a map. And in this case, I'm going to create a map called the Ford probe. And this variable is now going to be sort of a combination of all the other things because I want to group them together. They're all related to each other. They all represent the same basic thing, the same car. So I want to group them together so that they're easy to get to within the system, and it makes sense to me logically as I can go through and read code. Maps in TypeScript and JavaScript, or sometimes called objects, we start with just curly braces and we create that. And then we sort of do the same thing we did above. Syntax changes just slightly, but now we can say the make is a forward, the model is a probe, the year is 1992, and it's running, starts off false. All right, so I've created this map, sometimes called an object, but not technically in the same object-oriented programming thing, so I'm going to call it a map here. So I created this map, and now I can just reference values off of it and pass this thing around, and it's really nice. So I'm going to use JavaScript's console.log to go ahead and just output whatever this thing is to the console, so I can see what the software sees at this point. Ooh, that is not the one I wanted. You do not care about my i3 config. Let's go npx ts node. Okay, so the code runs and we see this output to the console that is basically the same thing we put here on line 6. So we have this map, we have this thing. Now we want to change its state over time. If values don't change over time, they're not really that very interesting in a lot of cases. So maybe we want to go ahead and say that we want to turn the car on, we want to start the car. Now a very common process within programming is not to sit there. You don't want to write the code forward probe dot is running equals true whenever you want to start the car, because it doesn't really represent what you're trying to do well. And very often we want functions to actually do this for us. Functions are things that we can define in the system just like variables, but they are like programmatic. You know, they are things, a code that executes that makes the state of the system change. So rather than writing line 16 every time that I want to start or stop a car, I'll simplify that. And it may not seem simplified at first, but bear with me. So I can say I want to create this new, this new property or new thing on forward probe called start. Now, just like we have strings and numbers and booleans above it, a function, at least in the case of TypeScript, is just still another thing. So I can just create this as a function, and the only thing the function does is it's going to say this, which is a special word in TypeScript meaning myself, meaning this map, this object. This dot is running. This is where I'm going to put my is running code equals true. I got to put it somewhere, right? But I want to put it here because then everywhere that I'm referencing this forward probe, rather than writing this, I just simply say start. I execute that function against the object. And now if I go ahead and run this code, what I should hopefully see is that I get an object that's running false and then an object that's running true. And although it's formatted a little bit different, yeah. So the very first object comes back as running as false. I call the start function on it. Now I get this is running as true. Now the reason why that's good is because when you start a car, it's more than just setting a Boolean value. You may want to do other things. And all those things together, I don't need to know them if I want to start the car. I really don't care. I don't need to know that the battery has to be hooked up to the wiring system and that the pump has to be running and that the spark plugs have to be. I just want to start the car. So I'm kind of delegating that to this object itself. And this is where the start of object-oriented programming comes in, is this idea that we're going to make these things in the system that are not only holding data or state like make, model, year, and is running, but it's also got brains. It's also got functioning code with it. Now, once people started doing this more and more and more, object-oriented programming courses or class languages came out of that. And there's a highly formal system to object-oriented programming languages, meaning that everybody basically does it about the same way. One of the reasons why the CDK can exist is because the JSII, and the JSII takes TypeScript code and compiles it into the other languages. Because when you're talking about taking something as simple as these class definitions and trying to replicate them across the environments, it's very, very similar. It's syntactically there are some differences, but that's a fairly easy problem to solve in some ways. Don't get me wrong, like the JSII I think is incredible with what it does, but the basic core concept of it is like we're just going to translate one thing into another. Boom, that becomes your language. And we can do that because all of these languages basically share a common definition of what classes and object-oriented programming are. So we're going to take this thing here. And because I don't want to have to now, let's say I go ahead and I create my second car. Say I Jeep Cherokee. Now when I go to create this thing, I basically have to come up here and copy this, paste this down here. And now this sucks because this bit of logic now is duplicated, copied and pasted, and you don't want that. So we're going to create this definition of what a car is to us. And that's our object in object-oriented programming. We're going to represent that as a class in the system. So I come down here. I say very simply, class. I'm going to define this thing new class, just like I have a variable on 14.6 and those things. I'm defining a class, and I'm going to call this, let's go with car. So I got a car. And now I'm going to kind of do what I did before. I'm going to say that it has these properties and it has this start function, but the syntax just kind of shifts around a little bit, not a huge big change. In fact, I'm trying to remember how I wrote this last night. I don't write a whole lot of classes, so forgive my syntax here. What I'm going to do is make these properties. Okay, so let me back up. So I create this class. The first thing I want to do on it is create sort of the data properties of the variables I had before, like make, model, year, and is running. And I copy and paste this down here because it makes it slightly easier just to go ahead and kind of fill in some of these things. When you're defining these properties and you're defining these types, you have to say, well, I want this to be a string or a number or whatever. And there's a little bit of this definition that goes through. And this is what's called the type system. I have to go in here and keep telling this class definition, okay, this is a string, this is going to be a number, and this is going to be a Boolean. Now, that's actually a good thing overall, because what it means is that my integrated development environment, my Webstorm and VS Code and various tools and everything can evaluate all these things that you've defined and tell you very basic things that you may have typed wrong. And that's a very good first start in programming languages. It's something that's generally missing from JavaScript, which is what made JavaScript a very difficult language to program in without really, really good testing in place. By the way, this is open. If you're watching along, thank you. And feel free to ask questions in the chat if I'm not being clear on anything, or if you'd like me to go into more detail about stuff. Continuing on, so now continuing to define out this car class in my system. I told it that it's going to have a make, a model, a year, and a Boolean of is running or not. And now I want to go ahead and say, I want start to be this function. However notice I got the red squigglies. Something here on my syntax is wrong, and I don't recall. Let's do this again. Why does it hate my syntax? Someone forgive me on my Typescript syntax. Okay, going off screen for a moment. If you know this, type it in. I forget how you define a class on Typescript classes, or a method function. Yeah, okay. I thought that was it. So I got my start method now, and I just put right in here. Can I grab my is running is true, the logic of the thing. And again, remember the whole point we're putting this function in here is because this is going to get more complex over time. there are going to be other things we want to do when we start a car. Maybe when we want to send out a message saying, hey, the car started. It's a very common thing that you want to do is, okay, I started this thing. I want to know when it's done. And I want this message to be told that it's happened. So you set that all up here. All right. So we got this class now. We got this definition. This is our object in our object-oriented programming. And now we can do things like say that our Ford probe is actually a new car. Now at this point I can come in here and say, well, the Ford probe dot model is Ford, and start setting up all these values like I did before. More common though is I actually want to, when I create this object on line 36, create this car, give all those properties at that time. So, and that just looks something like this. I'll come back over here and actually, in this case, and this is one of the reasons why I really like JavaScript to TypeScript. It's very often you can just copy stuff around, and that can be kind of handy. So now I'm just saying, like, okay, when you create the car, here are the initial values I want for all those properties. Now I got to actually go do something with that. So I'm going to go back to my car. And I'm going to create this thing called a constructor. A constructor is a special function on this class that is what gets called, the actual function that happens when I create the object right here. So what I do is I just say, it's literally the word constructor. And in here, I'm going to go ahead and say, you know, these are the, we'll call them props. That was weird, my screen flashed. Okay, so I've got these props. These props are going to be, again, the make, the model, the year that he's running. So I need to now just set this object up with those values. You don't get it automatically. There are some tricks you can pull with syntax to sort of do that, but I don't want to cover those here. I want this to be explicit. So I'm going to say this object, myself, my car that's being constructed right now, its make value. So you notice how like when I click, when I have my cursor on here, my IDE actually reminds me we're talking about this variable up here because it highlights it as well. This is one of the really nice things that IDEs can do, that it'll kind of hint you a lot about your code. And before, when I had all those red squigglies, I know, okay, I did something wrong. I got to fix this because I don't like red squigglies, just like Word. So we're going to say make equals props.make. Now notice the syntax here. We're just saying, hey, whatever this object is, the map that got passed in here, we're just going to go grab its make value. So let's collapse a little bit of this for now. I need to comment this. Don't want this because we're creating it below. Let's make this a little bit bigger. All right, so let's get rid of this for now. Just don't want you. There we go. Okay, so we got our car class now defined. We create a new instance of it. When we create that new instance, we say, here's our make, model, year, and is running we want. So now when we look at our output, we should see the same basic thing we saw before. Nothing really probably should have changed too much. Nope, we got an error. Let's find out where my error is. Nope, still a problem. I always forget. This is the lovely part of TypeScript, is you have to... I came from more of a JavaScript world where you can just sort of get away without telling it about types, but TypeScript, you know, especially in this case where I'm using Progen, which has a pretty strict TypeScript setup, I have to be, you know, explicit with things, or if I'm lazy, I can just say, you know, any and not care. Oh, so it's complaining now about not filling the rest of this code out. So let's do that. This is the nice thing, is it, you know, TypeScript at least does help you be good the first time. All right. Now let's see if that's better. Satya, good question. So is props a special keyword or something is in use as convention? So no, props is not a special keyword. This is another variable name like make, model, year is running, where it's whatever I decided to be. In fact, I can come in here and I can not move. I want to rename. So this is the rename command in Webstorm that, because my cursor was on the word props, it's letting me rename that, not just particular instance of the word props, but all usage. And it's smart to know what's, used where, because sometimes names overlap. But anyway, I can come in here and say that this is initial values. And it functions basically the same way. It's just whatever makes sense to me, whatever the convention is. Props, I use that in this case because props is a common convention over in the CDK. Thought it might translate well. So let's actually go back, Control Z. So, okay, now we see nothing much really changed. This code is run. The car, when it first gets created, it's running as false. So, this thing gets created. We output it. We see that it is running as false. We then ask the car to start. Now we output it again, and we see its state has changed. Its running is now true. Okay. This basic mechanic is the foundation of all OOP. You have an object, you create it, you manipulate that object through either setting values directly or calling these functions on it. And by wiring all of these objects in small parts together, you get a whole big functioning system. We've been doing this in application development for, the better part of 20, 25 years, 30, something like that. It's very new within the space of infrastructure as code and sysops, where, again, Bash and scripting and Ansible and these things that don't really have this object-oriented approach, never really come up. Cool. Thanks, Satya. Appreciate the question. All right, so let's now talk a little bit about how this basic thing kind of has some advantages to it and where they get leveraged within the system. This class definition that I have now is very robust. I can do a lot with this, and a lot of that power comes from the idea that when I define this class, when I define this new object, I don't have to start from scratch every time. I can say, okay, this thing over here, this other object, this other class that's been defined before, I want to use that as the basis, and then I just want to add or change these little things about it. And that really fundamentally changed a lot of the ways the software was being written at the time. And it has been a paradigm in use for, again, 25 or 30 years, and most languages do implement one way or the other. The CDK doesn't use a whole lot of the robust functionality here with a lot of the libraries, but some of the core things we're going to talk about now and how they relate to the CDK. If there's any questions, again, I try to do these things live in case people do have questions. If you have them, please ask them, even if you think maybe it's an obvious one because someone else probably doesn't. So thank you again for asking, Satya. So when I define this car class and I say I want to start with something else as the background, the basis, what that does is it alleviates this class's responsibility from writing a bunch of code. Like when I come in here and I start defining this thing, every time I write a line of code, it's something that I'm going to have to own long term. It's something I have to make sure is always working properly long term for 3, 5, 10 years, sometimes the life of software. So I want to make sure that I'm minimizing that as much as possible. There's always a cost with it. And the way that I can do that is say that, some of the things about how a car works are really more part of automobiles in general. So I'm going to sit there and say that I want to start with the basic idea of an automobile, another class called automobile. Let's go create it. Class, automobile. And for now, it's just going to do a do-nothing class, okay? Now, what I'm saying here is that, yeah, okay, I've got this car class, but, there are some things that might be defined here in the automobile that you just now get for free. For example, all automobiles have to be started. So I'm going to take this start function that I have here and actually move it out of this and give it to the automobile instead. Now, I also have to take this is running value here as well. And I got to move that up. So now the idea of whether something is running as part of the automobile, not the car, but because the car inherits or extends from an automobile, he also gets all that functionality for free. So now again, if I come down here, notice here how my IDE, my Webstorm has suddenly made this word highlighted. It's kind of an indication that something might be a little bit off. It's trying to grab your attention, trying to draw your eye to it. And when I put my cursor over it, it tells me I've missed my superclass's constructor invocation. All right, that may or may not make much sense to you. It always takes me a moment to understand what these things are saying. The superclass is another term from what I inherit from or what I extend, in this case, an automobile. So that automobile's constructor is not being invocated or being called. What's nice about this, and this is one of the things I love about Webstorm, let's see if this actually, I don't use it too often, let's see if it works. This link right here says insert superclass constructor invocation. This is like an auto fix. This is like, okay, I don't really have to know what that means, because if I hit that thing, it'll do it for me. And if you notice here too, now the word's no longer highlighted. The problem's been fixed. And maybe it wouldn't have been much of a problem, because if it was really a problem, it probably would have gone with a red squiggly line, but the yellow highlight's still pretty good. So again, if I come down here and run this code, nothing should have really changed as far as the functionality, the in and the out, you know. Well, now I have an error. Let's see here. Yes, property is running, has no initializer, and is not definitely assigned in the constructor. Most of the time, when I see these errors, the first thing I do is I'll just copy and paste this entire thing into Google, and there'll probably be a Stack Overflow question answering it or something pretty straightforward. In this case, I just happen to know what it means, which is that we'll give it an initializer. Initializer, or sometimes called a default value. We're just going to say, okay, we're going to start off with a value of false. Okay, cool. So that fixed that problem. Anyway, so if you notice, again, nothing much has changed, and that's actually a good thing. Notice how we're changing our code and being able to reorganize our mental model of how all of this works without actually changing the inputs and the outputs out of the system, which is a good thing. That's called refactoring. It allows us to make sure that our code is maintainable, that it's recognizable, that I can look at this in 6 months and not have to think real hard about what I meant to do or what I was doing 6 months ago. It's very, hopefully, simple and straightforward. So that is the basic idea. There are some more advanced concepts, but we're going to really just focus on what happened here and how this now relates to the CDK. The CDK does use some object-oriented programming concepts, although again, not much more than what we've discussed here. Specifically, when I create a construct in the system, I'm creating a class, or the class was already defined and I'm creating a new instance of that class. Basically, rather than my Ford Pro being a new car, I'm saying something like my bucket equals a new s30.bucket, where I put this, some bucket, and props for that thing. So here is my CDK code. Notice how similar these things are, and that's intentional. Now, the fact that most CDK objects have all CDK constructs are going to have these same 3 basic parameters. Not all classes do. It just happens to be those are CDK-based conventions. But it doesn't really change a whole lot. Think largely, this object here that you always hand to a construct as the props. It's the same props here. I just don't hand over an ID or a this or a scope is what we usually call it in the CDK to my card. My card doesn't care about those things. It's not a CDK construct. Okay. So the last thing I want to talk about is, so that's inheritance. If you ever go through and you see things in the code like it inherits from this thing, it's basically leading you to say, okay, you are looking at this object, but you're only looking at part of it. Here's the inheritance change so you can see what other functionality you got along the way. What was the automobile to this car? The last thing is interfaces. Now, interfaces don't come up a whole lot. In most cases, you may have been writing CDK code for a while and never really thought about them too actively, but there are two kinds of interfaces within the CDK. There are kind of data interfaces, and there are functional interfaces. So a data interface, so if we go back up here and we look at those things that we handed over to our car, our make, our model, our year, and whether we're running or not. I'm creating this object sort of on the fly here in Typescript, and that's again where I see like this curly brace opens, and where it closes I'm just creating an object like I did way up here at the top when I was doing these things. I don't put a function on it, it's just those guys right there, those four properties. I don't really care much about that object other than it has those four properties. Whether you created a class that had those properties, whether you created an object on the fly or whatever, however you got it there, I don't really care. But I do want to have those things really strictly defined because it helps in documentation. It helps in a person's, the IDE being able to pick up, and you can just kind of fill in values. There's a really neat feature that I use a lot with Webstorm where you say, just fill in everything I need to, and I'll just, fill in the strings or whatever. I'll show that to you here in a moment. That interface, it just says, well, I want those properties. So I'll say, again, but we're going to use a special keyword. Before we used class or var, now we're going to say an interface. We're going to have this interface called car props. And now we're going to basically do the same thing that we do up here. In fact, I'm just going to, I'm going to make this simple. This is a case where I can sort of copy and paste, and I'll explain why here in a moment. So I'm going to copy and paste this up here. Now I've defined the thing, and now I have to actually go use it. So back up here where on my car constructor I just passed in and I cheated and I said any. Well, now I can actually say no, I wanted this thing to match these values. I don't really care how that object gets put together, but I just want to have those things. Looks like I missed one. And interfaces are strictly saying, this is the definition. It doesn't have anything to do with any of the runtime code, really, not in TypeScript at least. But it says these things have to exist. So if I do that, now when I come back over here, let's say I didn't fill in some of those things. This should be complaining real bad about it right now, but it is not. And I'm wondering why. It should be. Double check something. There we go. Okay. Notice here, sorry, I went through that really quick. So when I hit the props dot, my IDE, Webstorm, is smart enough to know, okay, these are the properties that should exist on there that are available. Now you notice everything that's gray under here, well, that's because it's coming from its own inheritance chain and other things that have been predefined in the system that kind of come for free with TypeScript, but you don't use them all that much, hence why they're really grayed out. But these guys right here, P tells me it's a property on this thing. See what it is and go, okay, it's supposed to be is running. That sort of thing is really powerful. I think long term, and something that you don't often get out of scripting, or you don't get out of, a bunch of, why is this still running? I thought I killed you. Yeah, it's fine. Sorry, I got totally distracted there. Really benefits long-term over the maintainability of your code, the readability. This is why I think a lot of people do enjoy writing CDK code, because when it comes to defining and creating these constructs, you are guided the entire way into doing it. You say, well, I know I want a bucket, And then I just know I have to put in this and an ID, and then that properties, and I say, okay, I just look at what's expected of that object, what the interface is of that object. And the names themselves will often tell me everything I need to know about how to wire all this stuff together. There'll be useful properties that say, like, don't create an S3 bucket in this case, or do create an S3, or whatever it may be. Very cool, very fun. Yeah, it's something we've gotten out of application programming in a long time, and I really love has been brought into infrastructure as code. So that's an interface that is more of a data type interface. It's saying that this object has to have these properties on it. Now, the other type of interface is kind of more of a functional interface. And these things are usually, but not always, completely separated, but you define them actually the same way. You say, call an iCar. Okay, so a convention with interfaces when they're functional interfaces is to put an I in front of them. With data interfaces, you don't. I don't particularly know why. It just seems to be the convention so far. So I create this iCar, and because it's a functional interface, I put an I in front of it. And now I can sit there and say that a car should always have a start function. Or if I just leave it at that. Yeah, I'll just leave it at that for now. And now one extra thing I have to do is I have to come up here and explicitly say, well, it implements an iCar. So again, I have to do a little bit of definition here on the class. Before I said, well, it extends from this thing and got me a whole lot of functionality along the way. And now I'm saying, well, it also implements this interface. It also has a function called start. And that allows me to kind of hand these things all around within a system without having to care much about where they came from. I don't have to care if this was necessarily a car that extends an automobile. It could be any other class. I could come up here and say, well, now I want to create a class called truck, and it implements iCar. Well, now, anywhere that I try to use an iCar, that particular interface, which will hand around and things, I'll show you here in a moment, hand around those things, I can guarantee, well, I can do this thing that I want to do without really caring about whether it's a car or a truck or a boat or maybe a jet. Anything that can be started, now I can just hand around and I don't have to care much. And that's really great. So in the case of, for example, a bucket, when you define a bucket in a CDK construct, behind the scenes, you're defining a CloudFormation AWS S3 bucket. And there are certain things that you can only change about a bucket when you initially define it. Things like what the triggers are on the bucket for when new objects get put into that bucket. A very common thing is to turn on that trigger and then go send information somewhere else for processing. Well, if you want to enable that, you have to have control of that bucket. You have to have that CloudFormation resource, manage it yourself, and you have to create a bucket to do it. And it's part of this definition, these properties that we pass in. But there are other times I want to work with a bucket that I just want to make a reference to its ARN or a setting, or I want to change something about it that can be done without having to own that resource. There are a few other things. I think creating access points is one of them, if I remember right. Don't quote me on that. But I don't necessarily have to control the bucket. I just want kind of a reference to it. And that's in the CDK, we use that a lot of cases where we say like from ARN, or I think there's like VPC from lookup and things like that, where we say, okay, we've got the ARN. We're going to just pass that around as some value in the system, not a big deal. Now go get a reference to that bucket, because there might be some helper functions on this bucket right here, this CDK bucket that I want to use. For example, I'm pretty sure, the grant read function. So if we say bucket grant read to some Lambda handler, right? I don't actually have to have control of the bucket just to create that IAM policy for the bucket. So this is a case where bucket could be a bucket that I created, or bucket could be a bucket from ARN. I think, again, not positive on the name, but some ARN in there now. and the code will still work the same. The reason we can do that is because of interfaces and the fact that you kind of you define the ability of these classes by these interfaces and what they can and can't do, and it's all this magic wiring that happens at that point. A lot of times when you go to look at something like a grant read, you'll see that what I hand to it is not necessarily a Lambda function, but this thing called iGrantable. That's a functional interface. And there's code that has to be implemented by Lambdas and all of these other classes that say, okay, when this grant read happens, here's how you respond. And interfaces make that possible. And it's the mechanism for doing it. So let's go take a look real quick. I want to kind of talk about also what this means in terms of the CDK documentation. So let me go. So let's say we go down to our bucket. Here on the bucket definition, we can see, what our namespaces are for the different languages. And now we start to see how it says it implements these interfaces. What that means is that anywhere we go to try to use a function in the system and it says, I need an I bucket, or I need an I dependable, or I need an I resource, you can use a bucket in that case. You can hand it a bucket and that'll work. Let's go back to, if we say, look at the grant read, notice the first thing it's given is an iGrantable. Again, it's referencing these things not by the actual construct names, but by the interfaces. By doing this, we can get a lot of flexibility in the system, but it means this documentation now I have to go, okay, what's an iGrantable exactly? Well, the nice thing is if I click on it, I'll go to the definition, and it now tells me all the classes that implement it, which gives me a clue of what I need to hand to a grant read function. I could add, pass into it Python function and Node.js function. We should see bucket in here, Lambda in here somewhere. Big old list of these things. Admittedly, it's not easiest to read through, but again, you look at that and you go, do I have one of those somewhere? Okay, let's hand it over. So, very common pattern you'll see. Most of the time it's a matter of just kind of understanding how to read these things let's go back again and walk through that one more time. So I go to the bucket and I'm working with this bucket and I say, well, looking at this class's, notice again, that's why we call it a class. This class has down here under its methods or its functions, they're synonymous for the most part. This grant read, I go, okay, I want to let something read from this bucket, so I'll use the grant read function. So I click on it. It tells me what I have to give to it. So an iGrantable. Notice the object's key pattern isn't any. It doesn't care. You can give it anything you want to. It's fine. Just give it something. Actually, you don't even have to give it anything because there's a question mark. But the first thing you have to give it is, again, an iGrantable. So clicking on that now tells me all the things in the system that are iGrantable and that I can hand to it. And I just have to figure out which one is that I'm using. So hope that helps. I think that's basically everything that I wanted to cover. If there was anything else you'd like me to go more in depth on, or maybe try to explain in a different way, or better if I lost anyone along the way, I certainly could have done that. Please let me know either on Twitter or here on the YouTube channel. I really appreciate it. The feedback is very, very, very helpful. So please keep it up. Thank you very much for coming today. As always, at Matt Bonnick on Twitter, and have a great day, and I'll see you next time.